Section 2 of the Chapter 4 test, calculation part and the vocabulary part. These are the angles in an isosceles triangle that are congruent. Should be the base angles, which is letter E. This is a statement that can be proven true using deductive reasoning. That is a theorem, which is K. The segment from a vertex to the midpoint of the opposite side, that's A median. This is the longest side of a right triangle, that's hypotenuse, which is O. This is something that we have to assume true, cannot be proven true, that's I, which is a postulate. The perpendicular segment from a vertex to a line that contains the opposite side, that is an altitude, which is G. When two figures have the same size, same shape, they are congruent, which is M. A line ray segment is perpendicular to another segment at its midpoint, that's perpendicular bisector, which is F. A side of an isosceles triangle is opposite the vertex angle, that is the base, which is N. This takes a larger angle and creates two smaller congruent angles from it, that's an angle bisector, which is B. The side that create, or two sides that create the right angle and a right triangle are legs, which is C. Looking at question number 2, or 12, I guess, says find x if kt is 3x minus 4 and kw is 2x plus 4. Just want to highlight the parts that we know that we're given. We're given kt, and we're given kw. Okay, those two segments overlap, so we want to use the 1/3 and 2/3 ratios. We got to determine now which parts we use. Well, K to T, that segment there goes from a vertex to the centroid, so that's the 2/3 part. So I'm going to write KT and KW. I want to make them equal. Okay, they're not equal right now. I've got to apply the 1/3, or sorry, the 2/3. So KT is 2/3 KW. KT is 2/3 KW, okay, and that should make sense. KT is smaller than KW. Now I just plug in, KT was 3x minus 4. KW is 2/3 times 2x plus 4. A couple things you can do. I think what you guys probably liked in class the best was multiplying the entire thing by 3 to both sides. So that 3 will cancel with the denominator there, and this 3 over here will give me a 9x minus 12 is equal to 2 times 2x plus 4. Now that becomes 4x plus 8. And this is 9x minus 12. Subtract 4x from both sides, add 12 to both sides. So x is equal to 4. And that's our answer for number 12. Going on then to number 15, maybe, if I can scroll down. There we go. It says if I were to draw a segment from a vertex angle and an isosceles triangle to the base at the midpoint, list all the things that this segment would be in respect to the isosceles triangle. I'm not asking what it does to the vertex angle or the base, but what type of segment would it be for the triangle. Okay, you're asking what is it for the triangle. Well, the two things that it would be are median. Hold on, there we go. Median and an altitude. Okay. Question 16, for the following picture, draw 3 altitudes for the given triangle. In order to draw the 3 altitudes, what you want to do for this first one is to extend that line there, okay, because I want to go from this point perpendicular to the side opposite, and the only way I can go perpendicular to the side opposite is if I extend that opposite side. So now perpendicular would look kind of maybe like that. Okay, so that's 1 altitude. The other altitude, I would have to extend this side here, and I want to go from, that side should overlap, but I want to go from that point there to this side, so that looks like that'd be perpendicular. And again, I just wanted a rough sketch, see if you knew what you were doing. And then from this vertex to the side opposite it would be this side over here. I would just draw, that little short line, but that one, but I want to go all the way through so it meets up with the other ones. And if you've done this correctly, which a little bit off, but they should all three intersect at the same point. So those are all your altitudes for that triangle. It's an obtuse triangle, so your altitudes intersect on the outside of the triangle. That point right there, we talked about in class being the orthocenter. On the back, if V is the midpoint of MS, then NV is a blank of triangle MNS. V is the midpoint of that segment right there. So then if that's the midpoint, then NV has to be a median. If NV is perpendicular to VS, and that's all we know, then triangle MNS has to be an altitude. If segment NV bisects angle MNS, see, NV bisects angle MNS, so highlight that angle, MNS. We're talking about this angle here, or that segment bisecting that purple angle. It says then Q, the point right there, is going to be equidistant from which two things? Well, it's got to be segment MN and segment SN. If NV is perpendicular bisector MS and Q is on NV, then Q is equidistant from what two things? So I'm going to highlight the parts that we're talking about. NV is perpendicular to MS. NV is the perpendicular bisector, so Q, any point on there, would be equidistant from M and from S. So from those 2 points. A blank triangle is a triangle where the medians, the angle bisectors, and the altitudes are all identical segments and are congruent. That is equilateral or equiangular. Either one's fine.